Hello everyone. In today's video, we are going to discuss about factory method design pattern. It is one of the most important interview questions asked in .NET or any other language interview questions. So let's go through it. Before going into the details of factory method design pattern, we will see what core problem it solves. So when a client code directly creates objects, it becomes tightly coupled to concrete classes, making the system hard to extend and maintain. And what factory method fixes? Factory method removes the responsibility of object creation from the client and pushes it to a dedicated place, which is called the factory. So now let's flip to Visual Studio and see how a factory method design pattern is implemented. Here you can see I have an interface called iBank account, which has open method. This iBank account interface is inherited by multiple classes like saving accounts, current account, fixed deposit account, and premium saving accounts. All of these accounts classes are providing bank account opening logic as per their class methods. If we go to account service class, we have open account method, which has return type of iBank account. It has multiple steps like KYC, initial deposit, and send welcome email. After that, it does the process of opening an account. So here you can see it has multiple if blocks and it is checking if account type is saving, then it is having account of saving account type, or if it is current account, it is having account of current account type. So it has multiple if else blocks, and on the basis of that, it is taking the instance of particular account type class. If in future we will add more account types, here you will have to add more account types if else block, and that will increase the complexity. So let's see the code in the client side. Here in program.cs, we have a main method and we have put the logic to open an account. Here, a direct instance of account service class is created, which is creating a tight coupling here. There are multiple problems in this pattern. Let's try to see them one by one. Problems with this design are: number one is tight coupling. Account service knows all concrete classes, saving account, current account, fixed deposit account. Violates open close principle. If we need to add salary account or any other account type, we must add it account service and add another if block there. So it violates open close principle. Next is hard to extend for different banks regions. If any bank has different types of saving bank accounts, you will have multiple if else conditions there. Unit testing pain. Services directly using new keyword here. It is harder to mock or inject different implementations. So object creation is mixed with business flow. That's where factory method helps. Now let's try to understand how these problems will be solved by factory method design pattern. Let's try to understand the same example that we went through earlier without factory method design patterns. Here again we have an iBank account interface and it is inherited by multiple accounts type. We have created an abstract bank class which has a factory method created as create account and for which return type is iBank account. We have another open account method which has the logic to open account and it's called create account method. Here you can see we have given implementation by different types of bank and they are inheriting bank class. They are giving create account method implementation as per their business logic or need. There is no need to put all the logic in single class and create a tight coupling. We get a new requirement to create a new bank implementation. We just need to create class for that bank and provide implementation for create account method as per their business logic. Now let's see the client code in factory method design pattern, how this create account factory method is used to create instances of different types. Now let's look at the client code, the place where the factory method pattern is implemented. Here in the main method, we first declare the variable of type bank. Notice that we are depending only on the abstract type, not on any specific bank implementation. This helps in maintaining loose coupling. Next, we assign this variable to national bank. When we call open account with the type savings, the national bank decides which specific account object to create internally by overriding the factory method. After that, we switch the reference to digital bank and again call open account with savings. This time a different type of saving accounts is created, maybe a premium saving accounts, but the client code remains completely unchanged. Here we can see the different bank classes are providing implementation of factory method as per their business logic. This demonstrates that the key advantage of factory method pattern, the object creation logic is encapsulated in the subclasses while the client just asks for an account using a common interface. So by simply switching the bank, we get different product implementations without modifying the main logic. That's the power of factory method, flexible, extensible, and clean code structure. Now let's understand what improved with factory method. Separation of concerns. Bank open account method handles the workflow. Create account in subclasses handles object creation. Open close principle. To support a new bank, just create a new subclass and override create account method. No need to modify existing bank or client-side code. Flexible product mapping. Different banks can map the same logical types to different concrete classes. This is very realistic in banking when we have different products for different bank or region. Easier testing and extension. You can now mock a bank subclass in test. So this was factory method design pattern explained in brief. Hope it was clear with these examples. If you like the video, please don't forget to like and subscribe the channel. Thank you very much.